friends, myself Joshi, Professor Joshi here. I am from Arts Technical Campus, Chas, Telangana. Today we discuss very important topic of electrical engineering, that is a DC machine, which belongs from electrical machine subject from semester 3. Okay. Then first of all start what is meant by electrical machine or what is meant by machine. Machine is a device which reduces the human efforts. Okay, that is called as electric. That is called as machine. What is my machine? Machine is a device which reduces the human efforts. Okay, there are two types of machines. First is a mechanical machine and second is an electrical machine. First is a mechanical machine. Mechanical machine and second is electrical machine. There are two types of machines. First is mechanical machine and second is electrical machine. In this, a mechanical machine is the machine where electrical power is converted into mechanical energy. That is mechanical machine. What is the electrical machine? The machine which converts electrical power into mechanical power. It's called electrical machine. Mechanical machine is the machine which converts mechanical power into electrical power. It is called mechanical machine. The machine which converts electrical power into mechanical power is called as electrical machines. That's all the types of machines: mechanical machine and electrical machine. After that, what is meant by electrical machine? The machine which converts electrical power into mechanical power. Okay, there are two types of electrical machines. First is a DC machine and another is a AC machine. DC machine and AC machine. What is meant by DC machine? The machine which operates on a DC power supply. It's called a DC machine. The machine which operates on a AC power supply. DC means direct current supply. AC means alternating power supply. The machine which operates on a DC power supply is called DC machine. The machine which operates on AC power supply is called as AC machine. These are the two types of electrical machines. Okay. After that, these electrical machines are also divided into two types. Means DC machine and AC machine also divided into two types separately. The DC machine is divided into first is DC generator, and second is DC motors. First DC generator and second is DC motors. After that, the AC machine is also divided into AC electrical machines is also divided into two types. First is AC generator. And second is AC motors. AC generator and AC motors. AC generators also called as alternators and AC motors also called as induction motors. Okay. After that, we look only the concept of DC machines and DC machine. We have to understand only the DC motors. So, what is the operating principle of DC motor? Operating principle of DC motor is depend upon the when current carrying conductor is placed in a magnetic field, it exerts the mechanical force. That is the basic operating principle of DC motor. When the current carrying conductor is placed in a magnetic field, it exerts the mechanical force. It's called as operating principle of DC motor. Okay. Then what are the types of that DC motor? The DC motors are basically divided into three types depending upon the passion of armature winding and field winding, or the connection of armature winding and field winding. There are divided into three types depending upon the fashion or the connection of windings. First is shunt motor, DC shunt motor. Second is DC series motor, and third is the DC compound motor. Three types of DC motor is shunt motor, second is series motor, and third is compound motor. Okay. Then now we look construction of the DC motor. Construction of DC motor is completely same as that of the construction of DC shunt DC generator. That means the construction of generator and construction of motor is same. Only when we apply mechanical input to the DC machine, it gives electrical power. When we apply electrical energy to the DC machine, it gives mechanical power. Okay, means when we apply mechanical power to the DC machine, it gives electrical power. That means it working as a generator. When we apply electrical energy to the DC machine, it gives mechanical power, means it acts as a motor. Okay. Now, what are the main constructional parts of the DC machine? There are 5 major parts of the DC machine. First is the yoke, second is the field winding, third is the pole, fourth is the armature, fifth is the commutator. Okay, these are the 5 major parts of the DC motor. In that, what I mean by yoke is a basic or the base of the DC motor. It provides mechanical support to the DC motor or the DC machine. That means it avoid the motor from the vibrations, or it provide a proper placement to the DC or proper base to the DC machine. It is the basic principle of or the basic application of yoke, and this yoke is made from silicon steel or cast iron material. Okay. After that, field winding. There are 2 types of winding in the DC machine. First is field winding, second is the armature winding. This field winding produces magnetic field outside the armature. That means the role of the field winding is very important to produce the magnetic field. This field winding is wounded on the poles of the armature. This field winding is generally made from the copper. There are 2 terminals of DC winding, field winding. First is F1 and second is F2. After that, poles. Poles are the outer sectional part of the DC machine. These poles enlarges the magnetic field area of the machine. The shape of the pole is like as that means this area enlarges the magnetic field, and the main or important function of the pole is that it provides place to the field winding. That means field winding is mounted on the pole. Okay. Next, armature. The armature is the actual current carrying part of the DC machine. The armature winding is also made from the copper, and the armature is also called as the rotor of the DC machine. That means it is the actual rotating part of the DC machine. After that, commutator and brushes. The commutator and brush assembly is the assembly which gives rotary energy to the stationary part. That means this commutator is a cylindrical cylindrical in nature and made from copper. Means it is completely copper cylindrical body. And the main function of that commutator is that it collects all the DC current, and this made up from a number of copper segments. Okay, these segments collect the DC power from the armature, and on the commutator there are two brushes are present. These brushes are generally made from carbon material, and these brushes collect DC current from the commutator, and it externally gives to the electrical sources or external sources. That means the commutator is a rotating part, but brushes are the stationary part. There is no any movement by brushes, because these are the stationary parts and commutator is a rotating part. But brushes continuously touches to the commutator and collect all the DC current from that commutator. After that, type of DC motors. Let us in detail study the types of DC motor. The first type is DC shunt motor. DC shunt motor. Previously we seen that depending upon the pressure or the connection of the windings, these types are divided. The first type is DC shunt motor. Let us discuss the construction of the DC shunt motor. This is the armature of the DC motor. Each armature having two terminals, A1 terminal, A2 terminal. After that, in the shunt motor, the armature winding is connected parallelly with the field winding. So we draw here field winding. That means field winding is shunted with the armature. Here the current flowing towards the field winding is called IF, and the current flowing to the armature winding is called as IA, and this is the load connected to the armature. It is denoted by L. This is the circuit diagram of DC shunt motor. Here we observe armature winding is connected parallel to the armature winding. This is the field winding. This is the armature winding. What happens here? The total current I is divided into field winding and armature winding. That means I is equals to IFA plus IA. Field current to the or armature current. In case of DC shunt motor, the field current, that is ISH, is directly proportional to the producing fluxes. Okay, means field current increases, the produced fluxes also increases, because the fluxes produced in the field winding. That means the shunt current is directly proportional to the fluxes, and it is not depend upon the armature current. Okay, and the field voltage is also constant. That means the produced fluxes also constant. Because of that, this type of motor is called as constant flux motor. Okay, this type of motor, DC shunt motor, is called as constant flux motor. Okay, is called as constant flux motor because the fluxes are not depend upon the fluxes are not depend upon the load or the field current. Okay, because of that it is called as constant flux motor. If the fluxes are constant, that means the speed is also constant. Okay, that means it is also called as constant speed motor also, and the speed of the motor is not depend upon the load in case of DC shunt motor. Now we look second type of DC motor, that is DC series motor. DC series. The name indicates that here the two windings are connected in series. First of all, draw armature, two terminals of armature denoted by A1, A2. In case of DC series motor, field winding is in the series with the armature. That means we have to draw field winding is F1, F2, and the whole connection is across the DC supply. Here total current I equals to field current equals to armature current, means current is proportional, current is equals to the IF equals to the IA. That means in case of DC series motor, current is not divided into field and armature. Both the currents are that is I equals to IA. That means the fluxes are totally depend upon the load current. That means fluxes are depends upon field current phi, and the field current is equals to the armature current. That means armature current equals to the phi. That means the fluxes are depends upon the load current. So this motor is not called as, or this is not a constant flux motor. Because of that, we have to connect load every time by using the DC series motor. Because if load is not connected to the DC series motor, then speed is always inversely proportional to the fluxes, and when the fluxes are minimum, the speed of the motor is tremendously high. Because of that, we have to connect it all time connected to the load whenever we start the DC series motor. So it is always remember that never start the DC motor without load. Okay. After that, third type is compound motor. Compound motor is also divided into long shunt compound motor and secondary short shunt compound motor. Okay, these are the two types of DC compound motor. First of all, long shunt compound motor. First, we draw here the circuit diagram. So what we observe here, there are two types of field winding. Okay, means if we observe only this half portion, we look like series motor. If we observe this process, we look like a shunt motor. Means it is the combination of series and shunt motor. Okay, this is the combination of series and shunt motor. So if we shunted the complete series combination, means this field winding and this armature winding, if we shunted the complete combination, then it is called as long shunt compound motor. Okay, and if we shunted only the armature of the motor, then it is called as the long short shunt compound motor. So here we draw also a short shunt compound motor. We have to draw field winding. After that, armature winding, and it is the short shunt compound motor. So we have to shunt only the armature. Now supply. So it is called as short shunt compound motor. If you shunted the complete combination, then it is called as long shunt. If you shunted only armature, then it is called as short shunt compound motor. These are the types of DC shunt motor, types of DC compound motor. Now, what are the applications of DC machines or the DC motors? Where we use this type of motors? Firstly, the major and popular application of the DC motor is that traction motor or the locomotive motors or the in the electrical trains as a motor. In case of traction motor, we use DC type of series motor. After that, elevators, cranes, conveyors, electrical small toys, these all are the applications of DC motors. So, are you understanding this concept? What we study here, what is meant by machine, what are the types of machines, what are the types of electrical machines, what are the DC machine, what are the types of DC machine, what is the major principle or the operating principle of DC motor. After that, what are the which parts are what part belongs to the in the construction, that is field winding, poles, armature, commutator buses, and after that we briefly explain types of DC motors like shunt motor, DC series motor, and DC compound motor, and lastly we discuss about the applications of DC motors. Okay.